Hello, welcome. Geometry section 8.4 today, right triangles and trigonometry. Trig ratios. We have a triangle here, a right triangle, triangle ABC with the right angle being C, and side lengths small a, small b, and small c. Note that these small letters coincide with the angle opposite of it. Here are the three trig ratios that we're going to deal with that exist here now. We have sine, cosine, and tangent. And each of these are focused at the angle A. So we have the sine of A equaling the opposite over hypotenuse, cosine of A equaling the adjacent over the hypotenuse, and tangent of A equaling the opposite over the adjacent. So now that may not make too much sense to start off with, so let's talk about what those things mean. We're focusing in at angle A, and we have three sides to define. We have what's known as the opposite, we have the adjacent meaning next to, and we have the hypotenuse. Now the hypotenuse is always the side across from the right angle, so always across from the right angle is the hypotenuse. The opposite and the adjacent switches between the two legs. The opposite side from the angle that you're taking is going to be your opposite, or the one furthest away from it. So from A, side little a will be the opposite side, and the adjacent will be the side next to the letter that we're talking about, which is right here for little b. So this will be the adjacent side. So now we have those listed. Taking a look at the sine A again, we have the sine A is opposite over hypotenuse. That means it's going to be little a over little c. Again, that's little a over little c. Cosine of A is the adjacent over the hypotenuse, which will be little b over little c. And tangent of A is the opposite over adjacent, so therefore little a over little b. Now there is a way to remember these, at least that I was taught when I was younger, and that's with the little phrase SOHCAHTOA. SOHCAHTOA. And SOHCAHTOA stands for sine, cosine, and tangent, and gives you the layout of all of those ratios. Sine, then we have the opposite hypotenuse, okay, as coincides with sine of A here. Cosine is a C, and that is adjacent hypotenuse, and then T for tangent, opposite and adjacent. Okay, and each one of those go along with that. So I'd write those down and take a look, because we're going to be using those a lot in the next section here. Alright, some formal definitions from the book. Pretty self-explanatory and the same as we just talked about. Alright, applying trig ratios. So we know what the trig ratios are. In the top left corner here, we have this angle, and the angle is actually a symbol, and the symbol is theta. So we have theta written, and from theta I would like to have us write the sine, cosine, and tangent of theta. Starting with the sine. The sine of theta, which again is the opposite over hypotenuse, will be 3 over 5. Why is that? Across from the of theta is the opposite. Across from the right angle is the hypotenuse, and next to the angle is the adjacent side. So I have sine again as 3 over 5, as it is the opposite over hypotenuse. If I was going to do cosine next, which we are, and that I would take the adjacent side over the hypotenuse, right? Because cosine is adjacent over hypotenuse. So that would give us a cosine of theta of 4 over 5. Lastly, talking about tangent, if we have tangent as opposite over adjacent, then the tangent of theta will be 3 over 4. So this is applying the trigonometric functions to a right triangle and its sides. Alright, now some questions. Find the sine of A. So just that same idea, given angle A as what we're trying to solve for. Well, we could label our sides. Across from A will be the opposite. across from the right angle is the hypotenuse, and next to it's the adjacent. Sine is opposite over hypotenuse, so therefore we will have 12 over 20, which simplifies down, taking 4 out from both, as 3 over 5, which would be B. So the sine of A is 3/5. And let's continue that with some other ones. Cosine of A. Cosine is adjacent over hypotenuse. So from A, we have the adjacent, we have the hypotenuse. So we will have 16 over 20. Take out a 4 from both, and we're left with 4/5. So C. Cosine of A is 4/5. Tangent of A. We have the opposite being 12, we have the adjacent being 16, so we have 12 over 16, so take out the 4's from both, and we're left with 3/4. So A as the tangent of A. Sine of B. Now we're switching angles here. At the top we have B. Across from B will be the opposite side. And then we will have 12 as the adjacent and 20 as the hypotenuse. Again, sine is opposite over hypotenuse, so therefore we'll have 16 over 20, simplifying down to 4/5. So the sine of B is 4/5, or C. Cosine of B. Cosine is the adjacent over the hypotenuse, so therefore that's 12 over 20. Take out the 4's, and we're left with 3/5. And that is B, 3/5 for the cosine of B. And lastly, tangent of B, opposite over adjacent, 16 over 12, simplifying 4/3, or D. So that is applying the trigonometric ratios. Alright, now let us use trig to solve for missing sides, which is really one of the best functions of using trigonometric identities. To set up and solve for x and y, there are some things we need to know first. If we're given that this is the angle we're working with, we label our sides opposite, adjacent, and hypotenuse. If I am trying to solve for x, which is the opposite side, and I know one of the sides, and that's the hypotenuse, then since opposite and hypotenuse are involved, I need to use a trig function that uses both the opposite and the hypotenuse. And the trig function that uses both opposite and hypotenuse is, of course, sine. So sine of theta is equal to the opposite over hypotenuse. I know my values are, I can fill in. I know that instead of theta, my angle is actually 43. And instead of the opposite, I can put x. Instead of the adjacent, or hypotenuse, excuse me, I can put 18. And now, what I need to do is I need to solve. I need to get x by itself. And to get x by itself, I will multiply 18 on both sides. And I'll be left with x is equal to 18 sine of 43. And then my approximate value will give me 12.275. Now, how do you type this in your calculator? You type in just as is, 18, the sine button will probably give you parentheses, put 43 in, and then enter. You need to make sure that your calculator is on degree mode instead of radians. If you get an answer on your calculator that is not 12.275, you probably have it in the wrong mode. Similar situation for the y value. What we're going to do is now utilize the adjacent and hypotenuse, which is cosine. So you have cosine as adjacent over hypotenuse, the information that we know. The angle is 43, the adjacent side is y, and the hypotenuse is 18. Multiply 18 on both sides. And then we are left with y is equal to 18 cosine of 43, which is approximately 13.16. So that is solving for missing side lengths, giving an angle of a right triangle and a side. Alright, next problem here. It says find the missing lengths. So we have our angle, 47 degrees, 12, x and y. From 47, y is the opposite, x is the hypotenuse, and 12 is the adjacent. So if I'm going to solve for either one of these sides, I need to first figure out which trig function I'm going to focus on. In the first one, I will focus on the tangent function, which is opposite over adjacent. Opposite over adjacent will give me y over 12, which is similar to the last problem. Filling in the information I know, it gives me tangent of 47 degrees is equal to y over 12. Multiply 12 on both left and right. The reason to do so is it'll cancel out. And simplifying then, y is equal to 12 tangent of 47, or approximately 12.868. Next one, solving for x, I'm going to use the adjacent and the hypotenuse, which is of course cosine. So the cosine of theta is equal to the adjacent over the hypotenuse. Filling in the information that we know, we will then have the cosine of 47 is equal to 12 over x. Now here's where the difference comes in for the rest of the problems, from the rest of the problems we've done so far. The variable is on the bottom of the fraction on the right side. If we simply multiply by 12 on both sides, it would not cancel out the fraction on the right. What we need is we need the variable to be alone. And I can't just get that by multiplying it by 12. What I did with the problem on the left was I multiplied by 12 on both sides because 12 was the denominator. And here I have x as the denominator. If I multiply by x on both sides, just like a number value, then the two x's will cancel out, and I'll be left with x times cosine of 47 is equal to 12. And now I don't necessarily want that, but at least gets rid of the fraction. The next thing that I have to notice is that x is being multiplied by this cosine of 47. And it really has to be thought of as just another variable. And if I have two variables or two things being multiplied together, to get one to the other side, I can just divide. So if I divide both sides of the equation by cosine of 47, then I'll have x by itself. And that's what we'll do. I have x cosine of 47 is equal to 12. I will divide both sides by cosine of 47. On the left, that cancels out, and I'm left with x is equal to 12 over the cosine of 47. And then I typed in my calculator, and I have approximately 17.595. The difference with the calculator when you're typing this in is you're probably going to want to put in this key sequence. 12, division sign, parentheses, cosine, probably kicks out its own parentheses, 47, close, close. Now it might work without the double set of parentheses, but I would get in the habit of putting the double set of parentheses in there, as we will use that further down the line. And here we have another problem where we solve for the two side lengths. Good.